Odd and even functions. So when we look at functions, they can fit into three categories. They can be odd, even, or neither. So if the function's going to be even, it will follow this rule that f of minus x will actually equal the f of x. And for an odd function, it will follow the rule that minus f of minus x will equal f of x. Now you might see the rule for the odd function that looks like the f of minus x equals the minus f of x. It's actually the same thing, where the minus I have is just moved over to this side. So you can see the minus has been moved over here. But I like using this definition here because it relates it back to our original function. And it makes it a lot easier because you only have to check one thing against the original function. Now, odd and even functions have some geometric properties. And let's have a look at two functions that you should memorize as being even and odd. So an even function that you should know is that f of x equals x squared, which is just a parabola with the vertex at the origin. And an odd function you should memorize is that f of x equals x cubed, which is our cubic function going through the origin. And the geometric properties we should memorize is that an even function is symmetrical about the y-axis. Let's write that down. So it's going to be symmetrical about the y-axis. And an odd function is going to be symmetrical about the origin. So being symmetrical about the origin is kind of tricky because we have to think about the graph rotating using the origin as a turning point. So imagine these two quadrants rotated using the origin as a pivot point and everything on this side being shifted this way. You can see it's been reflected or rotated, sorry, into this position here. Let's have a look at an example how we can use this. So let's say we have a function x over x squared plus x cubed. And we want to know whether that function is odd, even, or neither. Well, our rules for an even function is that the f of minus x equals the f of x. And for an odd function, the minus f of minus x equals the f of x. We already know what the original function is because that's been given to us, so we know these two. So we need to find the f of minus x and the minus f of minus x. So let's go ahead and do that. So let's first find the f of minus x. So all that is we're just replacing x wherever we see x with a minus x. And I like putting a bracket to just make sure we know we're doing the right thing. So we've got x has been replaced with minus x. The x squared is replaced with the minus x all squared plus minus x all cubed. So wherever we have x in our original function, it's just been replaced with a bracket and a minus x. Let's just simplify that. So we end up with minus x over minus x all squared is positive x squared, and minus x all cubed gives us minus x cubed. So basically, if you're squaring a negative, it becomes positive. If you're cubing a negative, it becomes negative. And if we just take that one step further, if the power is even, you get a positive. And if the power is odd and you've got a negative, it stays negative. And hopefully we can see that the f of minus x ends up being this, and it's not equal to our original function, because we've got this being positive and this is negative, and that was positive and that's now negative. So we can definitely say the function is not even, but let's check if it's odd now. So we can look at the minus f of minus x. And all we have to do here, we already know the f of minus x, it's this, and we can just put a negative in front of the whole thing. So it ends up being negative outside of our function for f of minus x. So we can just put our minus in our numerator. So it ends up being x over x squared minus, whoops, that's the x squared. Minus x cubed. And does that equal our original function? Because that's the rule for the odd function. The minus f of minus x has to equal the original. And it doesn't, because the only change is that this positive is now negative. So we should have had a statement here saying that it doesn't equal the f of x, and this one also does not equal the f of x. So therefore, f of x is neither odd or even.